In previous sessions, we talked about concrete specifications, and from this session onward, we will address the specifications of reinforcing bars. Rebar is the short form of reinforcing bar. It is also known as reinforcing steel or reinforcement steel. As you know, concrete is weak in tension, and we reinforce it with steel bars or wires to resist the tensile stresses. As a structural engineer, you specify the type, grade, size, number, and even location and spacing of rebars. Reinforcing steels are produced per different ASTM standards for specific chemical and physical performance. There are various types, grades, and some other specifications for reinforcing rebars that we will discuss about them through sessions 5 to 9 of this chapter. We will learn these specifications according to ASTM standards, ACI 218, CRSI, and some other books. If you are interested in following these tutorials, consider subscribing to this channel and pressing the bell button next to it to be notified of new tutorials. In this session, I will talk about different rebar types and their applicable grades. In the next session, we will focus on their geometrical and mechanical characteristics. In the 7th session, we will learn in which components and structural systems we are allowed to use a specific type and grade of rebars according to Table 2224 of Chapter 20 of ACI 218. To complete all the subjects that relate to reinforcing rebars, we need to have sessions 8 and 9, and we will talk about these topics shortly. Most of the things I'll tell you throughout these 5 sessions are based on Chapter 20 of ACI 218, so consider reading this chapter by yourself too. In this chapter, we can read about steel reinforcement material properties, properties to be used for design, and also the durability requirements for rebars. Steel reinforcement includes bars and wires. Steel bars refer to hot-rolled reinforcement, and steel wires usually refer to cold-rolled reinforcement. These reinforcements are produced in plain or ribbed types. About the material properties of non-pre-stressed bars and wires, we should refer to section 22. At the beginning of this section, it has said that rebars of this category shall be deformed, and plain bars or wires are permitted to be used only in spirals. Most of the time, we deal with deformed bars in structural engineering, so I prefer to focus on them. To know the differences between rebars and wires, search on the internet yourself if you are curious about them. Okay, let's have an overview of different types of rebars. As you see in this picture, there are several different types of reinforcement bars. Each of them has a specific application in reinforced concrete design. Rebars made based on ASTM A615 are named carbon steel. It is the most common of all the reinforcements. The reinforcing steel grade is a value to specify the yield strength for which the reinforcing steel was manufactured. For example, ASTM A615 grade 60 yield strength is equal to 60 ksi or found 120 megapascals in calculations. The grade 60 bars are the most widely used rebars, and it is probably the reinforcement type and grade that you will use for your project. Note that A615 reinforcing steel doesn't have good weldability, so welding it can lead to brittle connections. Different grades of this type are available in Table 2213A. About the second row of this table, we will talk in the next session completely. The second most widely used type of reinforcing bars is ASTM A706, low alloy steel deformed bars conforming to the ASTM A706 standard are intended for applications where controlled tensile properties restrictions or chemical composition to enhance weldability or both are required. This type of rebar must meet three requirements. Firstly, tensile property requirements for ASTM A706 grade 100 reinforcement shall be as specified in these tables, and bend test requirements for ASTM A706 grade 100 reinforcement shall be the same as the bend test requirements for ASTM A706 grade 80 reinforcement. The second one is about its elongation capabilities. Uniform elongation requirements for all grades of ASTM A706 reinforcement shall be as specified in these tables, and uniform elongation shall be determined as the elongation at the maximum force sustained by the reinforcing bar test piece. Finally, for all grades of this type of reinforcement, the radius at the base of each deformation shall be at least 1.5 times the height of the deformation. This requirement applies to all deformations, including transverse lugs, longitudinal ribs, grade ribs, and grade marks, and intersections between deformations. About the details of these tables, we will talk in the next session completely. ASTM A767 galvanized reinforcing rebar is coated with a zinc layer that would provide corrosion protection. It is applicable exclusively to hot dip galvanizing of reinforcing steel, which involves completely cleaning the rebar and then immersing it in molding zinc. The molding reacts with the steel surface to form stratified zinc iron alloy layers. This type of reinforcing bar is usually used where corrosion may be an issue, such as in bridges or tanks containing liquids. ASTM A775 reinforcing steel has an epoxy coating that protects the bar from corrosion. The coating, which is typically green, is applied before fabrication, similar to ASTM A767 reinforcing bars. Epoxy-coated bars are used in environments where erosion may be an issue. Note that chips in the epoxy can lead to concentrated corrosion, so care needs to be considered when handling epoxy-coated bars. Similar to ASTM A775 reinforcing steel, ASTM A934 reinforcing steel is also epoxy coating. Coating for ASTM A934, which are applied after fabrication, are typically purple or gray. ASTM A955 reinforcing bars are made of stainless steel, which provides resistance to corrosion. Certain alloys can be manufactured to be used in applications where controlled magnetic permeability is required, such as in slabs or walls surrounding medical equipment that is sensitive to magnetic items. ASTM A996 reinforcing steel is produced by heating and re-rolling train axles or steel rails into deformed reinforcing bars. Bars made of axle steel are designated with A, and those made from rail steel are designated with R. ASTM A1035 low carbon chromium reinforcing bars are high strength reinforcing bars with yield strengths of 100 KSI and 120 KSI, designated with grade 100 and grade 120 respectively. These reinforcing bars are commonly used in applications where the high yield strengths can help reduce congestion. ASTM A1055 reinforced bars have two coats of protection for corrosion, a zinc layer underneath and an epoxy coating. This was almost all the types of rebars that a structural engineer should be familiar with them. Different types of reinforcing steel can have special chemical restrictions and special requirements. About these requirements, I will talk in the next session. But before that, we need to have good perception about the characteristics of a stress strain curve of different types of rebars. In the next session, we will have a complete review of these topics and some more other important geometrical and mechanical properties of rebars. Thank you very much for following these tutorials and the time you spent in this channel. See you in the next video. Goodbye.